We're going to look at 8.3, graphing general rational functions. So this is a little bit more involved than what we were doing yesterday. So we'll start with yesterday so we can kind of make sure that we understand what's going on. Do you remember how to graph these two functions? So the first one is when we have a constant on top, and then the second one is when we have an x that has a degree of 1 on top and an x that has a degree of 1 on the bottom. So let's look at the asymptotes for the first one. So remember that the vertical asymptotes are where you set the denominator equal to 0 and solve for x, which in this case will always be h, or, and then the horizontal asymptote is y is equal to k. The second equation over here, remember that you have to set the denominator equal to 0, solve for x, and that will be our horizontal or our vertical asymptote. And then for the horizontal asymptote, remember that it's equal to the leading coefficient on top divided by the leading coefficient on bottom. What is the domain and range? So the domain and range for both of these is the same. X is an element of all reals where x cannot be where the vertical asymptote is. And then y is an element of all reals where y cannot be what the horizontal asymptote is. So what do these graphs look like? Remember that they kind of had the shape where we have a couple of asymptotes, and then we have like this shape going on in between them. All right, let's continue, and again, stop the video anytime so that you can take notes completely. So this is a general rational function, so don't freak out once you see this. I know it looks pretty crazy. You don't even need to write that down, but I just wanted to show you that's what the definition of it is. So we're going to look at these rules, all right? And so you kind of want to write these down so that you have all the information. The first part is when you find the intercepts, you basically are going to set the denominator equal to 0. So you might want to write that down since that might make more sense to you. Set numerator equal to 0. Set numerator equal to 0. And that's where the x-intercepts will be. And then for the vertical asymptotes, this next part, this really means set denominator equal to 0. Okay, so you might want to write those down instead of the q of x and p of x because you might not remember where those are. And then the horizontal asymptotes, notice where m and n are in the problem. I highlighted them in pink and then put a little blue box around them. So we're looking at the degrees. So when the degree on top here is smaller than the degree on bottom, then the asymptote is just, horizontal asymptote is just at 0. And we just draw that line at 0 and that's it. If these two are the same, which is kind of like what happened yesterday when we had a 1 and a 1 here, then we do the coefficient of the top divided by the leading coefficient of the bottom. So it's these two numbers, just like what we did yesterday. And then if m is greater than n, so if this top number degree is bigger than this guy's degree, then there is no horizontal asymptote. And so we'll have to do this thing that has in behavior. And the in behavior equation, notice, is linear in this case. So y is equal to a sub m, so there's what a sub m is, divided by b sub m, leading coefficients, raised to the m minus n power. So in this one, it's usually linear for us because we're in algebra 2, but that can also be nonlinear. So we're going to make a t-chart, and we're going to use our intercepts. So we're going to choose, I put the intercepts in just because they're equal to 0, and that makes it nice. We're going to choose 2 to the left of the vertical asymptotes. So whatever we get in step 2 will be what goes in our numbers. And we'll choose 2 x's between them and 2 x's to the right. And again, right now we're just writing down these steps, and this will make more sense when I start doing an example. Again, pause the video if you need more time to write stuff down. So now let's look at this example. So we're going to write this example down, and we have to decide kind of what this is. So we look at this. This guy has a degree of 0. He has a constant on top. And this guy has a degree of 2. So whenever you have a degree more than 1, you're always looking at the second set. And really the steps are just the same. Step 1 is set the top equal to 0. We want to find what the intercepts are, the x-intercepts, and then the second step is to find where the horizontal asymptotes are, or sorry, vertical asymptotes are. So let's go ahead and start. So we have our equation down, right? We wrote the equation down. We're going to set the denominator equal, or sorry, the numerator equal to 0. That's where the x-intercepts are. So 4 equals 0. There's nothing to solve for because there is no x. Therefore, there's no x-intercept. So this will not touch the x-axis. Then we do the vertical asymptote. So we're going to set, I'll write it here, set denominator equal to 0. So we're going to set the denominator equal to 0, which is what I did here, and we're going to solve. So I'm going to minus 1 from both sides, take the square root, and when you take the square root of -1, remember you get plus or minus I. Anytime it's imaginary, that means that there are no vertical asymptotes. So there will be no vertical asymptotes, which we'll address that a little bit later. And now we can look at the degree. So this guy has a degree of 0, right, because he doesn't have an x showing. And this guy has a degree of 2. So that means that m is less than n, right? The degree on the top is smaller than the degree on the bottom. So we're going to make a t-chart. Usually, remember we put where the vertical asymptotes are. If there are no vertical asymptotes, then I always just use these same numbers every single time. So then I do -2, -1, 0, 1, and 2. And plug those points in to the equation. So we're going to have 4 over -2 squared plus 1. So that'll be 4/5. And then we'll have 4 over -1 squared plus 1. So that'll be 2. And then 4 over 0 squared plus 1, which will be 4. Then we plug the 1 in, which will be the same as what we got before, 2. And then this one will be 4/5. All right, so we don't have to worry about n behavior this last step because that only is true when m is greater than n. All right, so now we're ready to graph. Look how exciting this is. So we've got the horizontal asymptote at y equals 0. Remember that this is here because whenever m is less than n, the asymptote is automatically at 0. So we've got that in there. Check. Now we're going to go ahead and graph these points. -2, 0.8. -1, 2. 0, 4. 1, 2. All right, and then there's those points. And then this guy just goes along the asymptote. Remember not to touch him so you don't disintegrate. Go up, down, and along. So it looks like a cute little mountain. Right? We don't have those in Kansas, so you might be confused. But that's a mountain. So now let's do our domain. X is an element of all reals. Because there is no vertical asymptotes, there's no restriction on x. Y is a little bit weird. He's technically a real number, but notice where he can be. Y, the biggest that y can ever be is 4. So y has to be less than or equal to 4, and the smallest that y can ever be is 0, but it can't be equal to 0 because there's an asymptote there. So that's our domain and range. Super cool, huh? All right, so let's look at this bad boy here. X squared divided by x squared minus 1. So again, it looks kind of crazy, but you just follow the steps. It's like cooking. You just have a little recipe here, and away you go. So step 1 is to set denominator equal to 0. So x squared equals 0. Take the square root of both sides, and we get x equals 0. So we have an x-intercept at 0. Now we have the vertical asymptotes. Oh, I wrote denominator again. Dang it. That's supposed to be numerator. Numerator. Hopefully you're yelling at me through the computer screen like, oh my gosh, you silly girl. So let's try this again. Now on the bottom part, we're going to put set denominator equal to 0. Okay, so that's where this x squared minus 1 came from. Set it equal to 0, that's the difference of two squares, so it factors. And we get plus or minus 1. You can also add 1, take the square root, and get plus or minus 1. So now we have 2 vertical asymptotes. Now we look at this, look at the degree. So we go up here, we look at this degree, we look at this degree, we notice that they're both 2, so we're like, hey, that's equal. So whenever it's equal, it's the coefficient of the top, there it is, divided by the coefficient on the bottom, there he is, and 1 divided by 1 is 1. So that's where our horizontal asymptote is. These other guys we don't have to worry about because they're not true. Now we're going to make our t-chart. So on our t-chart, what I like to do is I like to put each of those on here. So I have the intercept at 0. We have -1 and +1. So the -1 and +1 came from the vertical asymptotes, the +1, right? And you pick 2 numbers to the left. So I'm just going to pick 2 numbers that are smaller, so this would be -2 and -3, and pick 2 numbers between. I have 0 in between -1 and 1/2, or -1 and 1. But what a good idea is to pick 2 numbers that are also in between there. So like +1/2 and -1/2. And then we have 2 numbers to the right. So look at all those cool numbers. Because we really want to get a good idea of what's going on to the left of the asymptote, what's going on between the 2 asymptotes, and what's going on to the right of the asymptote. So I'll make this a little bit clearer on the next slide. See, look how pretty that is. So we have the 0. We understand where 0 came from. That's the asymptote. I put them up here the time that I made this PowerPoint. So this would be 0 squared over 0 squared minus 1. And so 0 on top, that's how we get the 0. And then we go back and we do the same thing for the next number. So now I'm going to do -2 squared divided by -2 squared minus 1, right? So that would be 4 over 4 minus 1, which is 3. So that's how we got the 4/3, so on and so forth. And then we get 9/8, -1/3, -1/3, 4/3, 9/8. So again, hopefully you see how we got each of those numbers. If not, please ask a question tomorrow in class. So now let's go ahead and graph these guys. Maybe they're girls, I don't know. So 0, 0, that's what the intercept is. Remember, we had an x-intercept at 0, and that's where that guy came from. So then I have -2 and then 1 1/3. So -2, 1 1/3 is right about here. So you can see that. I probably should change colors, so let me make it black. Right? And so then we have -3 and 1 1/8, which is even closer to the asymptote. Don't touch it so you don't disintegrate. And then go across, curve them up. There we go. Oops, he's supposed to go straight along there. Okay, so now it looks pretty. So then we have -1/2, so I'm in between these 2 little asymptotes here. And I'm going to go down -1/3. So hopefully you can see that little black dot. And then we're going to go +1/2 down 1/3 as well. So this is going to make a parabola in here. Oh no, almost hit the asymptote. And then we're going to go 2, 1 1/3, and 3, 1 1/8, even closer. And we draw in this guy. Alright, and that's what our graph looks like. So it's not too bad. Kind of ugly there with this kind of wrong looking thing here. Make that prettier. There we go, beautiful. So now we want to do our domain. X is an element of all reals, except X cannot be wherever those vertical asymptotes are. So that would be plus or minus 1. Y is an element of all reals, except for Y cannot be 1, because that's where the horizontal asymptote is. And that's our domain, and that's our range. All right, so let's look at this equation. I know this looks really crazy, and you're probably tired of doing these, but this is the last one, so that's a good reason to celebrate. So we notice that this is of the third type, right? A general rational function, not a simple one, because we have this exponent of 2 up here. So if we were doing this, we kind of groan a little bit, but then we're big kids, so we'll move on. So the first step is to set the numerator. Look at me writing the right word the first time. Setting the numerator equal to 0. So that's going to be x squared minus 3x minus 4 equals 0. Quadratic, so we'll factor What two numbers multiply to make -4 and subtract to make 3? You're like 4 and 1, yay. So -4, +1, always the opposite, right? So we've got the two intercepts. So that's where it's going to touch 0 on the x-axis. Now we have the vertical asymptotes. Those come from setting the denominator equal to 0. So again, this is just like following a recipe when you cook. You're just going step by step by step. So we have x minus 2 equals 0, solve, and we're like, yay, we got x equals 2. And then we look at the degrees. So the top degree, m is equal to 2. The bottom degree would be here, but he doesn't have a degree showing, so therefore that means that n is equal to 1. Right? So we're going to plug these into our equation. So we look at this first one, and it says a to the nth power. That is the coefficient, the leading coefficient of the numerator, which is 1. So this guy's a 1. This is the leading coefficient of the denominator. So this is also a 1. And then we have an x. So far we have y equals 1 over 1x raised to, we subtract these, m minus n is 1. So this is where our end behavior is going to be at y equals 1 over 1x. All right, and then we'll do our t-chart stuff here. So now we're going to plot our points. These first 2 points are just our intercepts. So sometimes I don't put those in the t-chart, but I wanted to remember what they were for the other slide. So that's where that 4 is 0. Those are the x-intercepts we got in the very first step, and the -1, 0. So the 2 would actually be here that we got, and it would be undefined. That would be where our vertical asymptote is. And we would pick 2 numbers to the left. So if we look at where -1 is, or sorry, where 2 is, here where this asymptote is, we would want to pick 2 numbers to the right. Now 4 already has one. You might want to pick another number outside here, like 5, just so you can see what else is going on. See the what the line is doing, what the equation's doing. And then here we have the 1 and the 0, because on the other side we have 1 and 0, and those are to the left of the asymptote. So we're picking 2 numbers to the left and 2 numbers to the right. And since we only have 1 vertical asymptote, we don't have to pick 2 numbers in between. Hopefully that makes sense. So we take each of these x's and plug them in. So I'm going to have like 1 squared minus 3 times 1 minus 4 over 1 minus 2. Right? We figure that out and we get 6. And then we do this again. But we put 0 in, so we have 0 squared minus 3 times 0 minus 4 over 0 minus 2, which -4 over -2 is 2. And you keep doing this with each of these x's. And probably I should have put 5 in since 4 is an asymptote, so I'll go ahead and do that too. So 5 squared minus 3 times 5 minus 4 over 5 minus 2. So we'll end up with 2. And so now I'm going to plot those points. So I have 1, 6. I have 0, 2. We have 3, -4. And then, of course, we have 4, 0. And then we also have 5, 2. I went ahead and graphed one more, so I'd have 3 on each side. Now, the last part of this is to do the end behavior. So I'm going to change colors. The end behavior is just kind of a line. It's going to look like an asymptote, but it's not really an asymptote. It's just where the end behavior is going to be. It's a guide. So remember that the end behavior was y equals x. So y equals x, remember, it looks like this. So the y-intercept is 0. And then the slope is up 1 over 1. And I'm going to put these little points in here just so I know where the end behavior goes. So it kind of looks like an asymptote because it's like this dotted line, but I'm just using this as a reference to know where the end behavior is going to go. And this will make sense in just a second. Okay, so what happens is, change back to black. So this is going to go along here, and it's going to follow these points, and it's going to keep going till it gets the end behavior, and then it just follows along with the end behavior. So same thing here. This one comes from the top, hits these points, and then it keeps going in that direction till it gets to the end behavior line, and he just connects all those dots, and that's what that end behavior means. So hopefully that's making sense. That's how the graph ends. It goes along that end behavior line. So now we have the domain and range. X is an element of all reals. except x cannot be 2 because that's where our vertical asymptote is. Y is an element of all reals, and there is no horizontal asymptote, so we just leave it like that. All right, so make sure that you understand these. We want you to answer the question, how do you tell the difference between these three types, the two simple graphs and the general graph? And then how do you find the appropriate horizontal asymptote for this equation and predicting end behavior? So those are the answers those are the questions I'd like you to answer tomorrow when you come to class. So you'll have those answers in your notes, and I'll check them, and you'll be a superstar. Yay, notes are done.